I'm going to share my screen. Our whole message is that individual action does matter, and it is power in numbers that allows a little difference here and there to spark a worldwide revolution. By Nicholas Wolff. I would like to share with you how to represent whole numbers using pictures and manipulatives. My name is Jessica Johnson, and let's talk about representing whole numbers. What are pictures and manipulatives? Manipulatives are objects that you can physically handle and manipulate, and they can be used to help students better understand how to represent whole numbers. And here is just a small example of the manipulatives that are available to use. There's some counting bears, links, unifix cubes. A picture is anything that is printed on a piece of paper. You can't actually manipulate a picture, but you can see it with your eyes. And a number line is used here to help represent a whole number. A Venn diagram can be used to represent a whole number. Manipulatives and pictures are used for so much than just representing whole numbers. They can use to be for students to understand addition, subtraction, multiplication, division, fractions, measurement, even probability. Why? Why should we use manipulatives and pictures? It can help students take an abstract idea and make it more concrete. Even though a picture is worth 1,000 words, being able to manipulate a physical object makes the first-hand experience better. And not to mention, using pictures and manipulatives is fun and interesting for teaching and for learning. Allowing students to use manipulatives and pictures to represent whole numbers allows students to put on their thinking caps and engage in critical thinking to solve problems. They will be able to better identify cardinal numbers, which tells you how many. They'll be able to identify ordinal numbers, which tells you the position. They'll be able to better identify nominal numbers, which tells you the name. So we have learned what manipulatives and pictures are. We have learned why we use manipulatives and pictures. Now let's learn how we use manipulatives and pictures. Let's say a student needs to solve for 4 times 3. Teachers can use manipulatives and pictures to help the student better understand how to solve the problem and how to represent the whole number. Here's an example. We have 4 groups, and the circles represent the groups. And in each group, we have 3 manipulatives. So this example shows 4 times 3 represents the whole number 12. We can use a number line. The whole number 4 is represented by the jumps. The dotted line is the jumps. We have 1, 2, 3, and 4. And then the ticks in between the jumps represent the whole number 3. 1, 2, and 3. So the number line helps the student understand that 4 times 3 equals 12. Our whole number is 12. Remember that math rocks. Now I'd like to turn the presentation over to Taylor.
Thank you. All right, let's get started. Problem solving with whole numbers in Venn diagrams. How do you get a whale shark? By using a Venn diagram. If only it was that simple. How do we problem solve with Venn diagrams? Let's start with what we know from the information given and organize it. So let's say we have a survey taken to see how many people like Coke, Dr. Pepper, or Mountain Dew. 60 people complete this survey. 24 like Coke, 22 like Dr. Pepper, 17 like Mountain Dew, 3 like Dr. Pepper and Mountain Dew, 5 like Coke and Dr. Pepper, 4 like Coke and Mountain Dew, and 2 like all 3, Coke, Dr. Pepper, and Mountain Dew. So let's plug in this information. Let's start with 2 that like all 3 and place it in the middle of the Venn diagram. Next, we're going to take the 4 that like Coke and Mountain Dew, subtract the 2 that like all 3, and we get 2 which will be placed in the overlapped areas of Coke and Mountain Dew. Next, we have 5 that like Coke and Dr. Pepper. Again, we are going to subtract the 2 that we already placed in the middle of the Venn diagram, and we'll be left with 3 that like Coke and Dr. Pepper, which we placed in the overlapped areas. Next, we have 3 that like Dr. Pepper and Mountain Dew. Once again, we subtract the 2 and place the 1 in between the overlapped areas of Mountain Dew and Dr. Pepper. Next, we have 17 who like Mountain Dew. We need to subtract the 2 that like all 3, the 2 that like Coke and Mountain Dew, the 1 that likes Dr. Pepper and Mountain Dew, which leaves us with 12 that just like Mountain Dew. Next, we have 22 that like Dr. Pepper. So let's subtract the 2 that like all 3, the 1 that likes Dr. Pepper and Mountain Dew, and the 3 that like Coke and Dr. Pepper. That leaves us with 16 that just like Dr. Pepper. Next, we have 24 that like Coke. We subtract the 2 that like all 3, the 2 that like Mountain Dew and Coke, the 3 that like Dr. Pepper and Coke, and we're left with 17 that just like Coke. So after that, let's ask ourselves, how many don't like any of these drinks? Well, let's start with the intersects of C, which is Coke, D, that is Dr. Pepper, and M, which is Mountain Dew. Add those together and we get 53. 53 minus 60, which is the total that took the survey, gives us 7. 7 that don't like any of these drinks. We're going to place 7 within the square, but outside these circles in the diagram. And that completes our problem solving.
I hope you enjoyed our presentation about problem solving using Venn diagrams and pictures and manipulatives to represent whole numbers. Bye, everybody.